Hey, Trig students, had a question on the homework that I assigned on page 224. So this is that first unit on page 224, problems 17 through 20. Okay. On the screen, I have problem 18, so you guys can go do the odds. Okay. First thing I'm going to notice right away is that this looks a lot like a quadratic that we're used to, right? This binomial, tangent plus 1, is the same as this binomial. So what we have here is an expanded form of the perfect square binomial, which we know factors into or multiplies, distributes into perfect squares on the outside, and then 2 of that inside term, right? So all I'm doing is distributing, multiplying these two, because remember the directions here say multiply and simplify. So we're going to multiply. We're going to get this new quadratic here, okay? We're going to lean after that on the associative and commutative properties of addition, okay? So first we're going to use the commutative property to say, hey, we can rearrange this top thing if we think of this minus secant as plus a negative secant instead. Well, the commutative property of addition says we can move things around and we don't change the value. So what I did there is I just put the secant right here, but I put the 1 with the tangent, and I just moved the 2 tan on the outside. So it helps if you put parentheses around everything so you know that what the chunks are. Then I use the associative property that says, hey, I want to do this this addition first, right? And the reason I chose to do that is because of this identity here, right? So what we can do then is we can then eliminate that and put secant squared of x in its place, right? Using this Pythagorean identity over here. Then we're going to get secant and secant squared wiping each other out. And you're going to end up with only 2 tan of x on the top and a tan of x on the bottom, right? Which then, since we are simplifying over multiplication now, we can just go ahead and cancel this. And we can say, hey, 2 tans divided by 1 tan ends up with just the 1 tangent, okay? So we're always going to be looking for those quadratic tricks. Here's another one, right? If I get something like this, well, that's a difference of perfect squares. So I can always conjugate that to its conjugate pairs, right? So all those things we did in college algebra, all those quadratic tricks, like the perfect square binomial, the difference of perfect squares, all of those tricks are going to come back. And sometimes it's just a regular quadratic that you have to factor, okay? So lean on those quadratic skills to break down these trig things a little bit more simply, okay? But again, just follow the directions. You're just making it as small as you possibly can. Hey, I can't get smaller than that, so I know I'm good, right? So always just trying to make it as small as you can. That's what simplify means, okay? All right, email me with any more questions. It takes a little time to make these videos, but I'd love to do them for you. I don't want you guys feeling confused and lost out there, okay? We could also set up like a Zoom meeting if you want to talk face-to-face so I can get your questions verbally. But yeah, just email me and let's keep in contact. Good luck out there, guys.